So suppose here we have a function, we have two functions, that is m of 5, 6, 7, and another one is m of 3, 5, 6, 7. So first we have to take as a decoder here. So here x, y, z are inputs, and this is a 3 to 8 decoder. So we will get m0s to m7, 8 outputs. So from these outputs, we have to design using the OR gate. This is a PROM. This is a PROM figure. So see here, there is no AND gate. So in the PROM figure, there is no AND gate. There is just OR gates, and that or number of OR gates will depend on the number of functions. So how many functions we have? Actually, we have A and B, two functions. Okay. So first one having the min terms 5, 6, 7. So we have to click that 5, 6, 7. 5, 6, 7. Uh, we have to uh, connect these 5, 6, 7 in a single OR gate. And for the next function, we have to take another OR gate, that is B. And using that B OR gate, we have to connect the other min terms, that is 3, 5, 6, 7. So connect these 3, 5, 6, 7s, and the final outputs are A and B. So this is the design of the PROM, sorry. And now in PAL, we have the first we have the AND array, and then we have a fixed OR array. Okay, so number of AND array, that will again depend on the function. So suppose here we have um, two functions, that is xy plus x z bar, another is xy bar yz bar. Okay, so first see how many AND gates are there. So xy, that means x into y. So there is an AND gate, and in the second term there is another AND gate, that is x into y z bar. And again in x z bar, see that is x into z bar. Okay, and in another function x into y bar, so there is another AND gate, and y into z bar. So we have four AND gates for designing our PAL. So first we have to take the input combinations, that is x can be have value as 1, or x can have value x bar. So x have two choice, x have two inputs, so as either as x or either as x bar. So y similarly have two input combinations, y either y or either as y bar, and z also in the same way, either maybe z or as z bar. So we can take these NOT gates like this. So the inverted inputs are also there, and the uh, x in inputs, x y z inputs are also there. So from these we have to put the inputs depending on our function. So first function is xy. So we have to mark x and y using this cross symbol, and put them into the AND gate, first AND gate. And second AND gate, that is for the second term of the first function, that is x, y, z bar. So we have to connect x and z bar, that is the inverted z. So in this way, we get x z bar. Similarly, for the second function of first part of the second function, that is x y bar, the x and y inverted are marked. And similarly, the last term of the second function, that is yz bar, are also marked, and they are put it in the AND gate, second and fourth AND gate. Okay, so now we have to take the OR array, that is number of OR gates, that will depend on the number of functions, that is how many functions we have. We have two functions as a and b. Second one will be b, that is a typing error. Okay, so we have two OR gates as a and b, and we have to connect the functions that are for the a and which functions that are in the b. We have to connect them depending on the function. So for the first function c, x, y and x, z bar are connected using that point, and for the second part, that is for the b function, that is x, y bar and y, z bar are connected. So this is the programmable AND gates and programmable OR gates. So these are the array logic, programmable array logic and programmable logic array devices. So I will show you another example using the Jamboard. Okay, then it will be clear. And now I will discuss the 7-segment display. So it is very important, that is the 7-segment display. First see, for displaying the 7-segment, we have to take 7 variables, that is starting from A to F, A, B, C, D, E, F, sorry, to G, E, F, G. Okay, so where we can use this 7-segment display, using we can use this in our digital clock or digital watch. We can see this in different display devices in the stations or in several display devices. So it is very much useful, and you all are familiar with this. So we can display using the light emitting diodes. um, See here, for displaying 8, you can see that except G, all, sorry, for displaying 8, all the 7 variables will be glow. Okay, will glow. So, and for displaying 0, except G, all other variables, that is A, B, C, D, E, F, will glow. So in this way, for you can easily design, that is for glowing 1 we have to take just only B and C, and for glowing 2 we have to take, for first you have to write in your copy, that is how we will write 2 in digital way. So for in that way you can get that which alphabets, that which letters will glow, that is A, B, G, E and D for glowing 2. See here, can you see? তোমরা দেখতে পাচ্ছো?
হ্যাঁ ম্যাম।
হ্যাঁ, so for glowing 3 we have to glow, that is A, B, G, C, D. In this way we can easily design a truth table. See here, this is the truth table to design the to glow the 7-segment display. So how we will glow 0? So except G, all other inputs will be 1. 1 means high. High means the voltage will be high, that is positive voltage or plus 5 volt voltage will pass through these LED devices. Okay, then we will get 0. So in this way, for glowing 1 we have to glow, that is B and C, and the other input variables or the other letters will be 0. Okay, so they will not glow except B and G. So in this way 2, 3, 4, 5, 6, 7, 8, 9, up to 9, because the decimal digits are starting from 0, it is to up to 9. So in this way we have to glow starting from 0 to 9, and our input combinations for with the letters A to G are in this order. So follow the truth table. And then depending on the truth table, we have to glow this. So following the truth table, you have to generate the K-map and the functions. Okay. So I am showing you using the Jamboard. Okay.
Ma'am, some students are waiting.
Okay. Okay. Now I am showing you using the Jamboard. The figures are very horrible. First, I will design the bell. Um, it is very much horrible. Okay, I am again trying. So first see, this is the function that we have in our question. Um, suppose there, it is another example. Suppose we have three functions named as x, y, and z, and a, b, c are the variables that we have. So from mobile, actually I am doing this, so it is very much horrible. The letters are very, uh, it is not understandable properly. So see, summation of m 2351. So these functions will be given to you for designing the PAL or PL, and for PLC also. The functions will be given to you. So this is the first step, that we have to do the K map for the from the functions to minimize the functions. Okay. So first you have to minimize this function. So write in your copy these functions and minimize this. Okay. Can you minimize this? Hello. এগুলো মিনিমাইজ করো, এই তিনটে দেখো করলে কি আসছে, আমি লিখছি। ফার্স্টেরটা দেখেছো, এম এম অফ 2357, এখানে কমা হবে 51, sorry, it last one is 1, no, last one is 7, 2357. This one is 7. তোমরা একটু মিনিমাইজ করো, ঠিক আছে? ফাংশন গুলো মিনিমাইজ করলে কি আসছে আমি দেখাচ্ছি। আর সেকেন্ড ওয়ান ইজ m of 015, 015, okay, and third one is 0235. হয়েছে? লিখেছো এগুলো?
Yes, ma'am.
হ্যাঁ, এবার এগুলো মিনিমাইজ করলে কি আসছে? মিনিমাইজ করলে ফার্স্টেরটার জন্য আসছে, দ্যাট ইজ x। আমি শুধু x লিখছি। x is equal to আসছে a বার b প্লাস ac, ঠিক আছে? তারপরে y এর জন্য কি আসছে, a বার b বার প্লাস b বার c, ওকে। and z এর জন্য কি আসছে, a বার b প্লাস a বার c প্লাস a b bar c. So write down these three functions. সবাই খাতায় আগে স্টেপ গুলো লেখো। ফার্স্টে হচ্ছে এটা লিখবে, ঠিক আছে, মিন টার্মস গুলো। নেক্সট মিনিমাইজ করলে যে ফাংশন গুলো আসছে সেগুলো লিখবে। লিখেছো? সবার লেখা হলে বলো। হ্যালো,
Yes, ma'am.
কতক্ষণ লাগে? হুম, এগুলো লেখা হলে তারপরে স্টেপ কি হচ্ছে? তাহলে এখন হবে থার্ড স্টেপ। সো থার্ড স্টেপে আমরা ডিজাইন করব হচ্ছে ইউজিং দ্যাট ভ্যারিয়েবলস দ্যাট we have variables a, b, c. So in our expression we have variables a, b, c. So we have to take these variables, and x, y, z are our outputs. Okay, so x, y, z are the output variables functions. Okay, so we have to take first the input variables, that is a, b, and c. আচ্ছা, আমি কিন্তু এখানটায় মোবাইলে করছি, ছোট স্ক্রিন, এর জন্য আমার আলাদা আলাদা করে ডিজাইনটা কিছু করছি, তোমরা কিন্তু একসাথে করবে, ঠিক আছে? আচ্ছা, আরেকটা জিনিস আমি দেখিয়ে দিই। আমরা যখন ইনভার্টার ইউজ করি, when we use inverter, the symbol is like this, it would be connected, but we can also use this buffer in this way. So this is called buffer, isn't it? But if we use this symbol, this circle will be connected. Okay, চলো আমি হাত দিয়ে করছি তো মোবাইল, এটা হচ্ছে না ভালো। These symbols actually used to design the PAL and PLA. Okay, so these are called the input buffer symbol. Okay, so first one, see the first part, that is the above part of the third diagram, that is not inverted. So if we have x as our input, so this also gives as x, but this lower part, that is the inverted part with an inverter output, so this gives us x bar. বোঝা গেছে? এই যে সিম্বলটা আছে, থার্ড সিম্বলটা, এটার উপর পার্ট দিয়ে যেটা আসছে আউটপুট, that gives the same result, that is x. If the input is x, the output is also x. But in the lower part of this diagram, that is with an inverted output, so we will get x bar. Can you see this? Hello, বোঝা গেল?
Yes, ma'am.
আমি মুছে দিচ্ছি, আরেকবার করছি।
Ma'am, some people are waiting outside.
আর জয়েন করতে হবে না, এত বেলা হয়ে গেছে। So you have to design in this way. তোমরা আলাদা করেও করতে পারো, দ্যাট ইজ তোমরা এ নিয়ে এখান থেকে আগে যেমন দেখালাম ওয়ার্ডের যে ফাইলটা ছিল সেরকমও করতে পারো, এরকম আর এরকম ফর ইন্ডিভিজুয়াল ইনপুট। বাট তোমরা এটাও করতে পারো যে এখানে একটা দিলে, এখানটা একটা নট দিলে, নটটা দিলে কি হলো, নটটা দিয়ে এখানে নটের আউটপুটটা আসলো, আর এখান দিয়ে ডাইরেক্ট আউটপুটটা আসলো। তোমরা যে কোনো একটা করতে পারো, ঠিক আছে? So this is the first part. আমার এখানে কিন্তু পেজে জায়গা নেই, আমি মোবাইল থেকে করছি, আবার বলছি তোমরা কিন্তু একসাথে করবে, ঠিক আছে? একসাথে মানে এর যে নেক্সট পেজে আমি, এটা 5 আছে তো, 5 by 5, আমি 6 by, মানে নেক্সট পেজে যেটা করব ড্র, তোমরা কিন্তু ওটাও এখানেই করবে, ঠিক আছে? আমি এখানে দেখিয়ে দিচ্ছি। তাহলে এখানে কি হলো, আমরা we are getting the 3 inputs, and for the 3 inputs we have 6 combinations. That is either it would be a or a bar, or b or b bar, or c or c bar. Okay, now you have to take you have to take um, the so how many number of AND gates are required? Actually, there are three input variables, that is A, B, C. So the number of AND gates will be 2 to the power number of variables. Okay, so number of variables 3. So 3 to the power 2, that is 9. So number of 9 AND gates are required. So there will be 8 number of, sorry, 9 number of AND gates. আমার আর জায়গা নেই, তোমরা এখানে 9 number of AND gates ডিজাইন করবে। ওকে, 9 number of AND gates, and you have to connect this AND gate depending on your function. So first function is, so first AND gate, suppose I am taking this as first, so this is A, this is for A bar B. So how we will connect this A bar B? A bar means from this is A bar, and this is B, and excuse me, কেউ বলছো কিছু? হ্যাঁ, হ্যালো হ্যালো,
Ma'am, I think some students are waiting.
আবার অনন্যা শুনতে পাচ্ছি না, আরেকবার বলুন। কোথায়? আর কেউ নেই? অনন্যা টাইপ করে দাও কি প্রবলেম আছে। হ্যালো হ্যালো, শোনা যাচ্ছে?
Hi, ma'am.
Yes, ma'am.
হ্যাঁ হ্যাঁ, ঠিক আছে। আমি জানি আজকে প্রবলেম হচ্ছে, কিছু করার নেই আমার। যাই হোক, তোমরা কিন্তু ড্রয়িংটা করবে খাতায়। আচ্ছা, তাহলে ফার্স্ট আমরা কানেক্ট করব কিভাবে? ফার্স্ট হচ্ছে যে ফার্স্ট অ্যান্ড গেটটা আছে ফর দ্য ফার্স্ট ফাংশন। তো আমাদের ফাংশনটা কি ছিল? সি अगेन। সো দ্য ফার্স্ট ফাংশন ফর দ্য এক্স is a bar b plus ac. So we have to connect in this way. So first we have to connect this a bar, that is a inverted output of a. So a bar with b, we have to put this cross symbol and put them into the first AND gate. Then the second function, second term was AC. So we have to connect AC, that is in a single line we have to make the cross for the A. This is for the A, and for C
And screen show হচ্ছে না।
স্ক্রিন শো হচ্ছে না। ও আচ্ছা আচ্ছা, এক মিনিট। হচ্ছে?
Yes, ma'am.
So in this way, this is for the second term, that is AC, and C for Y we have A bar B bar and B bar C. So A bar B bar, that is the third AND gate will not be used. Okay, the third AND gate will not be used, and we have to put a cross sign for this, and we will not mark anything, but we have to connect in this way. Okay, so for the Next, that is a bar b. For next a bar b, that is a bar and b bar. Sorry, a bar b bar. So this is b bar. We have to connect, mark as with the cross sign. So for the next variable, that for the next function we have b bar c. B bar c, so it is b bar and c is here, c, b bar c, okay. And the first, second, third, fourth, fifth, sixth AND gate will not be used again. So I'm showing you in the next slide, that is the sixth AND gate. So these are the A, B, C. So the sixth AND gate, suppose I am designing it from the sixth. So sixth will not be used. Seventh, eighth, and ninth. So for the seventh, we have our function a bar b plus a bar c plus a b bar c. So first one is a bar b. So sixth, a bar b. So a bar will be marked in this way, and this is for b. So a bar b is this, and a bar c. A bar c is a bar, and this is c, and last one is a b bar c. So a b bar, and this is c. So this is the ninth AND gate, that is a b bar c. Now in the next slide I am showing, but you have to design in the below portion of your page. Okay, so see. So these are the outputs of the AND gates, and we have to connect this with the OR logic, or with the number of OR gates that we have in our function. So we have XYZ as our function. So I tell you before that number of OR gate will depend on the number of functions. How many functions we have? We have a function as X, we have a function as Y, and we have a function as Z. So the gates are very horrible, but you have to design in your copy in a proper way. I cannot write Y here. Why? It is Y. It is Z. Okay. So there, these are the number. These are the OR gates. Yes, this is the OR gate. Now we have to connect these OR gates depending on the functions, or the depending on the terms, that is how many terms are present in which function. Suppose for X we have which function, that is a bar b plus ac, that are coming from this first and second, sorry. Uh, hmm. Actually, we should not mark it with the cross symbol here. We have to just put, uh, we have to connect in this way, that is, this is for the a bar b, and from the second AND gate we are getting a bar c, and third AND gate we have nothing, that is crossed, though it is crossed, but we have to put this, we have to connect this. So this is for the x. Okay, so our function is a bar b plus ac. So a bar b plus ac are connected in this way, and they are put in the first OR gate, that is for x. And for the y we have function, what we have a bar b bar plus b bar c. A bar b bar plus b bar c. So that are the output from the fourth, fifth, and sixth AND gate. Okay. So fourth, fifth, and sixth will be connected in this way. Are you getting my point? So they are connected just with the dot. Okay. And in the Z, for Z, we have function a bar b plus a bar c plus a b bar c. So these three functions, or these three terms, are the output from the 7th, 8th, and 9th AND gate. So this 7th, 8th, and 9th will be marked in this way. So these are the terms that we are getting from these three AND gate, and these are in the OR logic. So Z equals to a bar b plus a bar c plus a b bar c. So in this way, the three main terms are coming or are getting from the Z output. Okay. So this is the PAL design, that is the most commonly type of used PLD, that is programmable logic device, and this is PAL is the most commonly used. Remember, PAL, this is the design of PAL, that is the most commonly type of logic device, that is programmable logic device, PLD, programmable logic device. Okay, so next we will discuss the PAL. This is the P, sorry, PAL. Sorry, it was discussed. Now we will discuss the PLA, logic array. Okay, programmable logic array. So programmable logic array, it is a type of fixed architecture logic device with programmable AND gates followed by the programmable OR gates also. And here we have to find out first the truth table. The first table is to design the truth table, um, and the second step is to minimize that functions that we have from the truth table. That is the second step. And then we will design our circuit, that is the third step. So there are three different steps. Okay, so first step is the truth table. Suppose we have a function for y1, uh, sorry, A, B, C are the inputs, and we have a function output as y1 and y2. So if the truth table is like this, that is A, okay, I am erasing this PLA. I am putting the input and the output variables here. A, B, C, and this is y0, sorry, y1 and y2. So টেবিলটা তোমরা কমপ্লিট করো, আমি টেবিলটা কমপ্লিট করছি না। And suppose we have a function so like this, that is zero zero, these are also 0. If the truth table will be given to you, then it is okay. If it is not given, then you have to design the truth table depending on the minterms, that in which positions you have one. Okay, suppose we have 1 for 100 position, and we have y1 as 1, 100 position, we have 1, and the others are 0, and we have 1 2 3, now it is 1, and then it is also 0, and then it is again, it is 1 1 0 0, and then last one is 1 1. Hello, hello.
Yes, ma'am.
হ্যাঁ, আমি বলে দিচ্ছি কোথায় কোথায় 1 হবে। y1 টা 1 হবে হচ্ছে তোমার 100 পজিশন, that is 4, 101 position, that is 5, and 111, that is 7. y1 টা 1 হবে, ঠিক আছে। আর y2 টা 1 হবে হচ্ছে তোমার 3 পজিশনে, আর 5 পজিশনে, আর 7 পজিশনে y2 টা, ঠিক আছে।
Yes, ma'am.
হ্যাঁ, তোমরা এটা নিজেরা ডিজাইন করো, মোবাইলে খুব অসুবিধা হচ্ছে। আচ্ছা, নেক্সট স্টেপ 2 হচ্ছে from the truth table you have to minimize the functions again. So we have to minimize this, and after minimizing we will get y1 as a b bar c bar plus a b bar c plus a b c. So if we minimize this, we will get a b bar plus a c, and y2, in y2 we have bc plus ac. Okay, so see here, ac comes twice, so we will drop this and we will take for a single term. So this is the first term, this is the second term, and this is the third term. লিখেছো তোমরা a b bar plus ac plus আর y2 equals to bc plus ac. This
ম্যাম
is the
এসিটা
second
কি করে এলো y1 এ?
y1 এ
ইয়েস ম্যাম।
ওটা মিনিমাইজ করে দেখো একবার,
ওকে ম্যাম।
ওটা মিনিমাইজ করে আসবে, ঠিক আছে? আমি তো এখানে অতটা করতে পারছি না, আমি এখানে খাতায় করেছি, মিনিমাইজ করো, করলে
ওকে ম্যাম।
আসবে। যে পজিশন গুলো আছে তাতে। আচ্ছা, নাও এবার স্টেপ 3 হচ্ছে আমাদের PLA টা ডিজাইন করতে হবে, প্রোগ্রামেবল লজিক অ্যারে। we have to design the programmable logic array. So আমাদের কি করতে হবে? ফার্স্ট হচ্ছে we have to take the input variables, that is a b and c. Then we have to take in this way. Again we have to take the inverted and the so now we have to connect this and put them into AND gates. So how many AND gates will be here? So AND gate will depend on number of terms, that is number of min terms that are present here. So here I told you that is we have to skip this AC because it comes twice. We have to we should not take this AC because it comes twice. We have to take these 3 terms, that is 1, 2 and 3, that is a b bar plus AC, and here y2 equals to bc. Only these 3 terms, because repetition will is not allowed here. Okay, so for this we have for these 3 terms we have 3 AND gates. Okay, so this is the difference with the PLA. PL. Okay, we have to connect this AND gates, and again here the output of the AND gates, and here also we have 2 functions, y1 and y2. For this is the y1, and again another OR gate, this is y2. Okay, and so number of programmable OR gate equals to number of functions present in the problem. So how many number of functions are there? That is y1 and y2, that is number of outputs. So that is the number of OR gates, and number of AND gates, programmable AND gates, equals to number of min terms not repeated. Okay, number of min terms within bracket লিখবে not repeated. So number of min terms, how many number of min terms are there? You have to take that number of AND gates in the PLA, that is programmable logic array. Okay, and in case of programmable array logic, we have taken number of so many number of AND gates that are depend on the number of inputs and its combination. So number of inputs, if it is 3, then 2 to the power 3, number of inputs, if it is 3, then it would be 3 square, or so see here in PLA, this is the PLA. So we have to connect in this way, that we have the functions as a b bar, so it is a, it is a B bar. This is A B bar, and another one term is AC. So AC is there. This is A and this is C. So this is AC. This is the second term. And the third term is, third term ta ki chilo? BC. So B is here and C is here. So this is BC. So now we have to connect the OR gates depending on the function, that is which function has which term, which minterm. So Y1 have these two minterms, that is A bar, A B bar. So this is the A B bar part. You may connect here in this way, A B bar, and this is AC. So A B bar and AC, and BC is here for the Y2. So no repetition is allowed, otherwise AC will come again. So, or if you want to put AC, you may put from here, that is AC for Y2. Repetitions are not allowed in case of number of AND gates, programmable AND gates that are required. But here you may use this term because it is already here. In the second AND gate, we are getting AC. So you can mark this as AC. So Y2 equals to BC plus AC. So you can add this BC and AC. You can mark this. Okay. So this is the PLA. These are quite similar, but the difference in the number of AND gates that are required. So in case of PLA, again remember this point, that is, in case of PLA, the number of AND gates depends on the number of minterms but not repeated. One minterm will come just for once. So number of minterms equals to number of AND gates, and OR gate equals to number of functions. Okay. Hello. বোঝা গেছে?
Yes, ma'am.
হ্যাঁ। আর নেক্সট ছিল আমাদের কি, 7 segment display. So 7 segment display তো সোজা, starting from এগুলো কিন্তু ট্রাই করবে তোমরা ল্যাবের জন্য, ঠিক আছে? ল্যাবে লেখা নাই বলে করবো না সেরকম নয়, কিন্তু নিজেরা বাড়িতে প্র্যাকটিস করবে। কেন স্যার কখন কোথা থেকে কি ধরবে, আমি তো একা নই, ল্যাবে তো আমরা দুজন আছি। সিডি, এটাই তো ছিল অর্ডারটা, আমরা একবার দেখে নিই কোথা থেকে এসছে। এখন একবার দেখে নিই এটা, that is so see the 7 segment display where it is used digital clocks, clock radios, calculators, and wristwatches and speedometer, and there are different radio frequency indicators. So these are the A, B, C, D, E, F, and middle is G. Sorry. So A, B, C, D, E, F, and middle one is G. Okay. So if you want to blow 7, so we write 7 as in this way. So 7 will blow for 7. We have to blow A, we have to blow B, we have to blow C. This is 7. So the truth table, in the truth table, we have to put this A, B, and C as 1, and other variables will be as 0. Okay? So for this, you have to design the truth table first. Then, if you if you design the truth table, then the circuit will be very easy. And if you want to design, suppose if you want to glow 8, so for 8, A, B, C, this is our handwritten 8, but the digital 8 is like this, that is all are glowing, all LEDs will glow. So this is our 8, isn't it? So all the variables will glow for glowing 8. Okay. Hello.
Yes, ma'am.
Yes, ma'am.
আচ্ছা, আমি এই নোটসটা তোমাদের পাঠিয়ে দিয়েছি, তোমরা একটু দেখবে, কিছু প্রবলেম থাকলে বলবে। তোমরা সেগমেন্ট ডিসপ্লেটা লজিসিম দিয়ে চেষ্টা করবে, ঠিক আছে? আমি নেক্সট দিন দেখবো, বাড়িতে চেষ্টা করবে কালকে। কবে আছে তোমাদের? বুধবারে? ওয়েডনেসডে আছে না ল্যাব? হ্যাঁ, 7 সেগমেন্ট ডিসপ্লেটা চেষ্টা করবে, আর বাকি দুটো আমি দেখবো আগে অ্যাসাইনমেন্টে কি আছে সেই দিনের জন্য, সেগুলো তারপরে। ঠিক আছে। আর এখানে প্যারিটি গুলো দেখেছিলে? আর নোটস তো আমি পাঠিয়ে দিয়েছিলাম সেদিন, তো তারপরে আর কন্টিনিউ করনি। প্যারিটি জেনারেটর, প্যারিটি চেকার দেখেছিলে? ইভেন প্যারিটি, অড প্যারিটি, এগুলো কিন্তু হঠাৎ করে পরীক্ষায় চলে আসে, 5 মার্কসে চলে আসবে। ঠিক আছে? আর কারো কোনো প্রবলেম আছে? কম্বিনেশনাল সার্কিট কিন্তু আজকে শেষ করে দেবো। হ্যাঁ, হ্যালো, আমরা নেক্সট দিন থেকে কিন্তু সিকোয়েন্সিয়াল সার্কিট স্টার্ট করব। ঠিক আছে?
ওকে ম্যাম।
ঠিক আছে, আজকে আর বেশি পড়াচ্ছি না, আমার খুব অসুবিধা হচ্ছে মোবাইলে। আর তোমাদের কি হয়েছে পরীক্ষায়, কি কি প্রবলেম ছিল? অনেক মেল পেয়েছি আমি, দুটো কোশ্চেন মনে হয় ভুল ছিল।
হ্যাঁ ম্যাম, ওই 10101টা অপশনে 21, মানে 21ই হবে,
21ই হবে। ওটার প্রিন্টিং মিস্টেক হয়েছে, 27 এসছে, ইট শুড বি 21। আর একটা কি বলছিলে? আর একটা কি যেন বলেছিল?
ম্যাম ওই এক্সপ্রেশনটা a + bc তে কতগুলো মিন
ম্যাম,
টার্মস,
নাম্বার অফ
নাম্বার অফ মিন।
নাম্বার অফ মিন টার্মস,
ওটা
ওটা করে
five
দেবো।
ওটা তো 5 হবে।
5 হচ্ছে? আচ্ছা,
তো অ্যানসারে 4 দেওয়া ছিল।
5 ছিল না?
ম্যাম
না।
আরেকটাতে সবার ডাউট আছে, ওই বুলিয়ান ওই কোশ্চেনটা
বুলিয়ান অ্যালজেব্রা ইজ বেসড অন
লজিক অর ট্রুথ।
লজিক, ওটা লজিক হবে।
ওকে ম্যাম।
ওটা লজিক হবে। ঠিক আছে, মার্কস নিয়ে ভেবো না, পরীক্ষাগুলো দাও। আর তোমাদের কারো কোনো লজিসিমে কিছু হয়েছে? লজিসিমে কেউ কিছু করেছো? আর হ্যালো, অরিত্র, অ্যাটেন্ডেন্সটা নিও। অভিষেক,
Yes, ma'am.
do you have any problem in logisim? for the lab class? Hello.
No, ma'am.
Okay. Then you have
No,
to
ma'am.
try for the 7-segment display, and today that I have discussed, that is PLA and PAL. Okay. And all of you have to see what are the assignments for the Wednesday. Be prepared for it, and try to avoid using the combinational logic analysis of the logician, and build your own circuit using the logic gates and the input output devices. Okay. If it is very difficult, then you will use. Otherwise, you have to try by your own. Okay. Thank you. I know you have so many difficulties in today's class. Okay.
Thank you.
Bye.
Thank you, ma'am.